Hi friends, welcome again. My name is Rajkumar and I'm here for the EBS class today. Um, so EBS is Elastic Block Storage and it's a service available in Amazon. So you might have heard about various storage systems like block level storage and file level storage. So block level storage is something where you get you get the storage in the form of raw disks, and then you have to format them and uh, format in the sense you have to create the file system on the disk, and then you have to mount, and then you can place your data over the file systems. Rather, the file level storage is something where you get the ready-made file systems, and you just need to access that file system, and you can put your content on that file system. So best example of file level storage is NAS, or if you worked on Linux, then the NFS servers you create is a best example of file level storage. And the best example for block level storage is the SAN storage, or the normal disks you attach in your system are the example of block level storage. So EBS is a block level storage device, and we are going to discuss more about this in today's class. So before we move to EBS, you might have heard about the other storage types in AWS. So you might have heard about instance store, which is also known as ephemeral storage, and you use this ephemeral storage with the instances where you need very high throughput and very high input output rate. So the problem with instance store volumes is you cannot reboot those machines, or you cannot start them again. So this type of storage is actually works like the way your RAM works. So they are like volatile type of storage. Once you put something, it will be vanished if you reboot the machine or if the machine goes down. Next is S3, which is object level storage. So we'll discuss about it later on, and EBS you already know, and we are going to discuss more about this. And there is one more, which is EFS. Once again, it is this is equivalent to NFS file systems you use in Linux. So EFS is available in AWS. So some properties we are going to discuss before we actually start the demonstration and the practical session of EBS. So EBS is a network block storage as a service. So you get the disks as a service, the block storage disks as a service through network. Designed for 5 nines of availability, that means 99.999% of availability is provided by Amazon for the EBS disks. Availability means the disks availability actually represents the available time for the disk. That means they ensures that the disk never goes down, right? So that is availability. EBS volumes attached to any EC2 instance in the same availability zone, so that is a condition. If you have launched your EC2 instance in one availability zone, you have to create your EBS volume in the same availability zone. You cannot span across the availability zones that way. Like you cannot create EC2 instance in one availability zone and EBS in another, and then you can create it. So you are supposed to create the EBS volume and EC2 instance in the same availability zone. If you do it in a different availability zone, then you will not be able to attach the EBS volumes with your EC2 instances. There is also a provision of creating snapshots, and we call it point-in-time snapshots for the EBS volumes, and these snapshots are stored in S3 storage. There is one more important point, like it is independent to Amazon EC2. That means you can create a EBS volume independently, and you can attach it to any EC2 instance you want, right? And if you want, you can terminate it anytime. But there is why we are saying that it is independent, because without even launching an EC2 instance, you can launch or you can create a EBS volume. Alright, now there are some basics which you need to understand before we actually start our EBS session today. So there is a term called IOPS. We normally call it IOPS, and it is abbreviated for input output operations per second. So normally what happens is any read and write operation you do on your hard disk is actually divided into small chunks of data read and write requests, and each request is counted in a number, right? So if let's say I have to access a file, that means I'm reading the content of the file, and for example, if the data chunk is 4 KB, that means you further divide the size of the file in the ratio of 4, and whatever the result is the number of read requests. So you also call it as an output request. So similarly, if you write something in a file, then the entire content which you're writing is further divided into data chunks, and accordingly you calculate like how many input and output operations you're doing on the hard disk. So bigger the number is, better the disk performance will be. Right. Next is throughput. So throughput is very similar to downloading or uploading speed of your data. So with what speed you can read content from your hard disk, and with what speed you can download the data is normally throughput. So the upload and download speed of your hard disk is the throughput, which is measured in MBs per second. Then we have latency. So this is again very important property of a hard disk. So latency is actually the moment you put a request to read something or write something, the disk doesn't start working immediately. So whenever there is a delay in processing the request, that means let's say you put a request at some moment, and then the disk started working after a delay of 10 milliseconds. So this delay exactly is called latency, and normally the latency should not go in double digit. So any latency which is in single digit, that is acceptable. So normally disks have a dependency between 0 to 10 milliseconds, so that is acceptable latency. Capacity is actually the storage capacity of the hard disk. How much data you can store on that disk is actually the capacity. And block size is also important. So size of each IO, that means as I said, the chunk of data which you read and write is actually the block size, right? Okay. Now there are multiple EBS volume types. One is general purpose SSD, we also call it GP2. The next one is provisioned IOPS. We'll discuss about them in detail shortly. So we're just going through the names. We have GP2, provisioned IOPS, and then we have magnetic HDD. We call them hard disk drives, and there are two options available for HDDs. One is called throughput optimized HDD. We also call it ST1, and there is one more which is called HDD, which is SC1. So we'll discuss about these in details one by one. So general purpose disks are actually, as the name says, they are used for general purpose kind of workloads. It supports a volume size from 1 GB to 16 TB, and the IOPS baseline is 100 to 10,000. So there is a concept of burst bucket for IOPS. We'll be discussing that in next few slides, but before that you need to understand like the performance can go from 100 to 10,000 IOPS for this for these GP2 disks. It supports a throughput of 160 MBs per second, and the disk latency is in single digit. Performance consistency is 99%. So performance consistency means it's not like sometimes the disk performs well and sometimes the disk performs below expectation. So the performance is always consistent, which is around 100%. So you can say it's 99% consistent. Next, provisioned IOPS. So Provisioned IOPS disks are used for IO intensive workloads. The applications which require huge IO, for those purpose we use provisioned IOPS disks. It supports the size from 4 GB to 16 terabytes, and the IOPS baseline is 100 to 32,000. So as compared to GP2, it is far, I mean, from performance perspective, it is far better than the GP2 disks. Supports throughput up to 500 Mbps, and it supports the latency is in single digit, and performance consistency is 99.9%, which is better than the GP2 disks. Right. Let's move to the next, which is magnetic disk. So there are two disks. One of them is throughput optimized, and okay, the previous two GP2 and IOPS disks, provisioned IOPS disks, they are actually SSDs. So you might have heard about solid state drives. But these magnetic disks, we call them HDD, we also call them hard disk drives. And the specifications of ST1, which is throughput optimized, are they are low cost magnetic storage, and the performance is defined in terms of throughput rather than IOPS. So the previous two disks, we were comparing their performance on the basis of IOPS, which was 100 to 16,000 in one, and the provisioned IOPS was 100 to 32,000. Right, but these disks, they are these magnetic disks, and specifically the throughput optimized HDD, their performance is measured in terms of throughput. So how many data, with what speed the data can be read and written to the disks. So these disks are used for large sequential workloads such as data warehousing, EMR, ETL, etc. And it supports a size of minimum 500 GB to 16 terabytes. So minimum disk needs to be, minimum volume can be of 500 GB once, if you want to create a volume of throughput optimized HDD. Maximum of IOPS is 500 per volume. Throughput is supported up to 500 Mbps, and important is bootable volumes are not supported. So if you want to install operating system on this disk, then this disk does not support that. The other one is also a magnetic disk, which is called HDD, and the almost everything is same. The only difference is these disks are called HDD. The reason being these disks are used for infrequent access workloads. So example, you have taken a backup and then you can store it on the cold HDD, and if at some day and at some point of time you require, I mean, something wrong happens with your servers and you need to restore your data from the backups, then these kind of storage devices are best suitable for such requirements. Alright, then there is a concept of burst bucket, but we'll discuss about this shortly. Before that, we'll take a lab session, and we'll see how a volume is created and how can you attach it to your instance and use it. So we already have EC2 instance running, and as of now we have only one disk attached to it. This is a RHEL 7 machine, so I can check how many disks we have. We have only one disk attached to it, which is /dev xvda with size 10 gigs. So what next I'm going to do is, on this EC2 instance, I'm going to attach a new volume. So I'll go to EC2, where I'm already on the dashboard of EC2, and there on the left pane I see there is a block there for elastic block storage. I'll simply go and click on volumes. So I already have one volume and I'm going to create a new one. So here you can choose which volume type you want to choose, general purpose or provisioned IOPS or any of the magnetic ones. So I'll go with the GP2 disk. Size, I'll say I'll take 5 GB only. So just 5 I'll mention, and since it is GP2, uh, so the baseline for IOPS is 100, and there is very important concept of GP2 disks, which is you get 3 IOPS per GB and per GB per second. So in every second, for every 1 GB of disk, you get 3 IOPS accumulated in the burst bucket. So the bigger the volume you have, the better. The bigger the volume you have, more number of IOPS will be credited in your bucket, and more the number of IOPS you have, the better the performance will be for the disk. So we will discuss this more through a slide, but let's move ahead. So we have mentioned the size is 5 GB. We have to also mention the availability zone. So we need to check in which availability zone our instance is. So it should be in availability zone AP South 1A. We can check if you want. So let me just open the EC2 instance. Here it is. And if you go and check the properties of this instance, or here itself it shows you that it is in AP South 1A AP South 1A availability zone. So similarly, referring the same, we will be using AP South 1A for this EBS volume, and nothing more than that. You can specify a tag, so name, and I'll say secondary disk. Okay, create volume. Alright, so the volume is created. I'll close, and once the volume is created, let me refresh the page. Yes, so the volume is created, the name is secondary disk. Now you need to see here the state is available, that means it is available to be used. So I'll select the disk, we'll go to actions and attach volume. Now here you need to specify the EC2 instance. So I have only one instance running. I'll just select it. Device name, it will pick automatically, so you need not to do anything here. Simply go and attach. Once the disk is attached, you can go to your EC2 instance, and if you see the status of your disks here, run fdisk -l, so you will find a new disk is created. You can see the new disk of size 5 GB available in your Linux machine. Next you need to do is, so it depends from operating system to operating system. As we are using Red Hat Enterprise Linux 7, so we need to first create a file system, or in terms of Windows you need to format this disk first before using it. So I'll simply create a file system using the XFS file system. So mkfs.xfs and the disk name /dev xvdf. Alright, the file system is created. Now create a directory, let's say mkdir / the directory name which you want to create. I'll say ITBrains. Alright, and let's mount the disk, which is /dev /xvdf on this directory. Once mounted, you can verify that ITBrains is mounted there, and the size of file system is 5 gigs. Now for some purpose I am just trying to put some data here in this directory. So I am in this directory called /ITBrains, and I'll create a file here, test file. So okay, vim is not there, no problem. I'll go with vi, and I'll specify something, file created on the 5 GB /ITBrains file system. Alright, save. Cool. So I just formatted the disk, mounted it on /ITBrains directory, and then created a file called test in that file system. So I'm done. So this is how you create a disk, attach it to the instance, and then format it and store your data over it. Now there is a concept of snapshots in EBS volume. Now how snapshot can be beneficial, we need to understand that.